Robotic Process Systems is proud to introduce the Opus configurable work cell. The Opus is a multi-axis closed-loop Cartesian robot on a heavy-duty base with full safety enclosure. Product can be delivered by the operator for batch processing or by conveyor for continuous inline processing. Several Opus cells may be joined together, automatically conveying product through multiple process steps. The Opus was completely designed and perfected using state-of-the-art three-dimensional modeling technology. This documentation principle leads the way for rapid custom configurations that are well proven in the design phase. The system is robustly built for durability and low maintenance. The motion elements feature precision Teflon-coated lead screws and anti-backlash nut assemblies driven by brushless, closed-loop servo motors, moving each axis of the Opus robot with a precision repeatable to plus or minus 1/1000th of an inch. The operator controls interface and programming is Windows NT, with powerful integration capabilities through familiar, user-friendly programming. True multitasking and user-configurable input and output commands are accessed through drag and drop functions. Initially, you will be asked to send samples of your product to RPS for process evaluation. We maintain a complete process development lab with steam aging, wetting balance testing, ionic contamination level, selective and point-to-point soldering, lead tinning, and laser marking capabilities. Your sample parts will be sent through our lab, where our technicians will create a robust process that will be applied to your complete RPS solution. Your process parts are returned to you with a video and a quote for a turnkey installation. The remaining video is partitioned for specific Opus applications. Real-life case studies are reviewed for point-to-point soldering, selective soldering, component lead tinning, dispensing, screw driving, and pick-and-place assembly operations. The point-to-point soldering Opus features a fully articulating soldering head that performs as a fourth and fifth axis of the robot. The solder wire delivery profile is precisely controlled for volume, total speed, and ramp. Hot iron, microflame, laser, or hot gas heat sources are available. When the hot iron is used, automatic tip cleaning and retinning is provided and incorporated as a standard feature of the process. All angles for the solder and iron approach to the soldering site are settable. The solder site point coordinates are taught by a jog and teach function. With the site located, a process subroutine is selected from the library. The subroutine contains all the specific information for the solder and iron coordination for the selected site. All process parameters within the subroutine are user configurable. This is a completely automated application of the Opus integrated with our Delta T preheat oven. The task is to solder spade terminals on a massive heatsink to pads on the PCB. Product is queued in the Delta T and maintained at the prescribed preheat temperature. When ready, a module is singulated within the oven and conveyed to the location nest of the Opus. The Opus moves to each site, soldering the terminals to the PCB. The unique subroutines specific to the different terminals are performed under complete program control until all joints are made and the process is completed. The finished product is conveyed to the next operation while the Opus cleans and retins the iron, preparing for the next cycle. In this application, two slides with locating nests shuttle product into the Opus. The operator populates the nests, matching the machine cycle. As the application varies, the Opus may be fitted with a laser heat source, replacing the more conventional iron. Here we see the laser reflowing solder-laden leads. In this application, the laser is coupled to the solder wire feed system. The advantages of the laser are non-contact with the product, no-tip cleaning, faster reflow times, and access to difficult areas. When localized rapid heating of a large thermal mass is required, RPS may use a miniature flame as the heat source. The technology stems from the jewelry industry, where the torch orifice may be as small as 0.010 of an inch. The flame is fueled by hydrogen generated from water. The generator is embedded into the Opus superstructure. With orifice size and chemistry selections, we can use this technology on delicate to massive applications. Selective soldering is the process of joining through-hole components to a PCB from the underside without disturbing SMT components mounted near the solder site. Traditionally, this process is accomplished using site-specific tooling or nozzles for flux and solder. Although this process works well once set up, the tooling lead times and costs, the inflexibility of the process, and the messy changeover makes this method unsuitable for high-mix job shop environments. In 1989, RPS pioneered the Gaussian solder wave for Texas Instruments. This technique replaced the conventional method with a truly flexible process. The Opus 3 is a combination of RPS process know-how and robotics, providing a unique solution for selective soldering. The printed circuit board is located in an articulating holder and robotically moved over a controlled spray flux nozzle and Gaussian solder wave. The spray flux station features precise control over the pattern and density of the flux deposition at each site. The Gaussian solder wave can cover the width and length of any connector or a single point under complete program control. Superheated nitrogen surrounds the Gaussian wave during the soldering process. The nitrogen contributes to the high luster of the solder while inhibiting bridges and icicles. The returning solder travels back into the crucible in an atmosphere of nitrogen, negating dross buildup. After the initial programming, the operator places the populated PCB into the holder of the Opus. The cycle start button is actuated and the selective soldering process starts. All sites on the board are first processed through the spray flux station, then through the Gaussian solder wave to the specific conditions of the program. Once a program is created, it can be instantly recalled back into service, making the system perfect for high-mix job shop requirements. The Opus will outperform hand soldering by 10-to-1 and traditional dip soldering by 2-to-1. The productivity and toolless process justify most installations within 3 months. With full process control over location of the solder sites, flux application, and soldering parameters, engineering and quality will rave over the results. The Opus 4 is our component lead tinning model. The system is configured to customer process requirements from standard features that include batch load or pick and place, flux, preheat, dynamic solder pot, nitrogen inerting, and post-cleaning stations. With interchangeable tooling, the Opus can be rapidly set up to run a wide range of components. Although the emphasis is on flexibility, the Opus 4 will outproduce manual lead tinning by 5 to 1, while providing a consistent high-quality process. In this application, the Opus 4 is configured to process 16 headers per cycle. The requirement is to tin the leads within 10,000ths of the body without any flux or solder contact to the body surface. This was accomplished at a rate of 6,000 units per hour. Dispensing is easily accomplished using positive displacement valves actuated by the Opus controls. Solder paste deposition in conjunction with hot iron or laser reflow is a common application. In this application, the Opus was modified to hold a fixture on a rotary mandrel that's operated under control of the Opus. The dispensing system fitted to the Opus and in conjunction with the rotary mechanism allowed for accessing to very tight, difficult to get to spots to place the solder paste. After the dispensing is completed, the fixture is removed from the mandrel and placed onto a reflow oven. This installation replaced 3 operators, justifying the cost of the machine with a 4-month payback. Here we see a combination of dispensing with a pick-and-place operation. Feeding and driving screws or nuts to programmable torque limits is a viable option to manual assembly. The Opus can be fitted with automatic tool changeout to drive a variety of hardware within one work cell without operator assistance. Where plant nitrogen is not available, RPS offers a low-cost, turnkey generator sized to the process requirements. Throughout this video, we have seen unique and dedicated applications of the Opus work cell. To learn about our solderability test equipment, custom automation capabilities, laser marking, or our exciting Harmony high-volume selective soldering line, call us or visit our website. In closing the video, please be encouraged to call RPS with your requirements and join the growing list of satisfied RPS customers.